This week on the show, we have 6 metrics for you for measuring your zpool performance. We have two-factor authentication with SSH on OpenBSD. How do ZFS maintains a file type information in directories, you always asked? This is the info we have for you. And everything old is new again. You have to look for that in the show. As well as Netcat Demystified in this week's episode of BSD Now. BSD Now, episode 268, Netcat Demystified, recorded for the 17th of October 2018. Hello, I'm your host, Benedikt Reuschling.
And I'm Alan Jude.
And while we have the fun of our time, of our lives, basically at MeetBSD right now, while you're watching this, we will be out of town, but we recorded this for you, and starting with headlines that go 6 metrics for measuring ZFS pool performance, part 1.
Yes. So this is a post over on the IX Systems blog helping to explain how your pool layout affects the performance of your system. They have some nicer graphics than we had when we explained all this in the ZFS book a couple years ago. So
with color.
The layout of a ZFS storage pool has a significant impact on system performance under various workloads. Given the importance of picking the right configuration for your workload and the fact that making changes to an in-use ZFS pool is hard, it is important for an administrator to understand the mechanics of pool performance when designing the storage system. To quantify pool performance, we will consider 6 primary metrics. First is the read IOPS per second. So how many separate discrete operations can you perform per second for reading and writing? And then there's the streamed read and write speed. So that is, if you're reading data that's all laid out in a row, it's a lot faster than if you have to read a little bit, move to a different spot on the disk, read a bit, move to a different spot, read a bit. You also have to look at storage efficiency based on how many hard drives and basically what percentage of the raw storage from all the hard drives are you actually able to use under the setup you create, and fault tolerance. How many drives can fail while you're still protected from data loss? So for the sake of comparison, we're using an example of a system that has 12 hard drives. Each one is 6 terabytes, and say that each drive can provide 100 megabytes per second of streaming reads and writes, which might be a little low compared to what you can get out of a 6 terabyte drive, but it makes for nice round numbers for math. And writes, we figure 250 read and write IOPS, because that's about standard for a spinning 7200 RPM drive. So we can visualize how the data is spread across the drives by writing these 12 multicolored blocks. So we have kind of like brown, rust, reddish, orangish, yellowish, 2 kinds of greenish, 3 blues, and 2 purples.
Nothing for the colorblind.
Or purple and a pink. Anyway, so we have 12 different colors. Hopefully they are somewhat useful to you. So the blocks are written to the pool starting from the brown block, number 1 on the left, all the way to the pink one in number 12. Note that when we calculate data rates and IOPS values for the example systems, these are only approximations, not exact. Many other factors can impact pool access speeds for the better, like compression and caching, or for worse, like CPU performance, not enough memory, or even just how exactly the blocks are laid out on the disk. There is no single configuration that maximizes all of the 6 metrics we talked about. Like so many things in life, the objective is to find the balance that best fits your workload. You need, basically fitting your workload, the performance desire, how much money you have to spend, and so on. For example, a cold storage server will likely want a pool configuration that emphasizes the usable amount of storage, so having the least amount of overhead. Whereas if you're backing virtual machines, performance may be a bigger deal and you want to use more mirrors. Or if it's storing really critical data, you might decide that more redundancy is more important. So let's start with a quick review of ZFS storage pools before diving into the specifics. A storage pool are comprised of one or more virtual devices called VDEVs. Each VDEV is comprised of one or more actual storage providers, like disks, which are typically hard drives. All disk level redundancy is configured at the VDEV level. That is, if you create RAID layouts or whatever, they're per VDEV. And each VDEV is responsible for providing the protection of its own blocks. And there's no protection between different VDEVs. So normally what we do is we create many VDEVs and we just round robin distribute the blocks across them. And then each VDEV in itself is responsible for not losing that data by applying the RAID transform to it. So if you lose an entire VDEV, you've lost a fraction of every block you've written to disk, basically. Well, a fraction of every file, most likely. And your whole pool will be unusable, basically, because you're missing a big chunk of all your data.
The redundancy there, yeah.
Yeah, the redundancy is at the VDEV level, so don't lose an entire VDEV. Because storage pools are made up of one or more VDEVs with pool data striped over the top of that, I'll take a look at the various configurations and look. So there are three basic types, striping or non-redundant VDEVs, mirroring, or RAID-Z. And RAID-Z has three different versions. This first section, we're only going to cover the first two because RAID-Z gets quite a bit more complicated, and there's a second post about that. Maybe we'll do that next week. So looking at the non-redundant VDEV. In this one is the simplest configuration. Each VDEV consists of only a single disk with no redundancy. When several of these disks are in a pool, data is striped across them. And we'll show you what that looks like. So the total usable storage space would be the sum of all the drives. There'd basically be no waste. When you write data to a pool made of striped VDEVs, the data is broken into smaller chunks called blocks and distributed across all the disks in the pool. So what that means is if any one of those disks goes away, you're going to be missing pieces from every block, basically, or every file. So you have absolutely zero fault tolerance, and this is a really bad idea. But it's important for us to show you what that ends up looking like. So the basic formula for the performance stats on that is your read IOPS will be however many drives you have times the speed of that individual drive. So if we have 12 disks all striped together and each one does 250 IOPS, we'll have about 3,000 IOPS of read and write speed. And then the streaming performance, we had 100 megabytes a second times 12, so 1,200 megabytes a second. And the storage efficiency will be the full 72 terabytes, so 100%. But the fault tolerance is 0. So when we look at the graphic, we see that our data is written across all of the drives. Basically, we take a chunk of data and we split it up and put it a little bit on each drive.
Mm-hmm.
So that works, but that's not very useful because, you know, if you lose any one of these disks, you're missing that chunk of data and it's gone forever.
Yeah, the more disks, the higher the risk.
Yeah. So now look at mirrored. In a mirrored VDEV consists of 2 or more disks. A mirrored VDEV stores an exact copy of the block on each member disk. So just like traditional RAID 1, traditional RAID 1 usually only supports 2 drives, but ZFS allows you to have as many drives as you want, so you can make really deep mirrors. All disks in a mirrored VDEV have to fail for that VDEV to fail. So if you have a 2-disk deep mirror, if one of the disks dies, that's fine. But if both die, you've lost all the data in that chunk and it's gone, which is why ZFS allows you to make 3 deep mirrors, or 4 deep mirrors if you want. So looking at the difference here, for your read IOPS, you get the same kind of performance as you would get from striping, right? Because when you read, because every disk contains identical data, you can read from any one of the disks and it'll be fine. So if we create a 12-way mirror, meaning we have one VDEV that contains all 12 disks. So every time we write a block, we write it to all 12 disks, meaning we get really terrible storage efficiency of 8%, because we only have 6 terabytes of usable space because we made all 12 disks copies of the same data. But in that configuration, your read IOPS are the same as striping, so you get all 3,000 IOPS, 250 times 12. But when you write, you only get the IOPS of one disk because you have to do that write IOP on all 12 disks. So you don't get any performance boost from having multiple disks. Whereas with reading, because they can work independently, you do. The same goes for reads and write speed. So your read speed will be 12 times 100, but your write speed will only be 1 times 100 because you're actually having to write that same 100 megabytes a second to all 12 disks, using up all 1200 megabytes a second of bandwidth. But your fault tolerance is 11. As long as one of those 12 disks stays alive, your data is still good. So as you can see in the graphic here, we write the brown data to all 12 disks, and then the green data to all 12 disks, and the blue data to all 12 disks. So while that's super redundant, it's kind of expensive to buy 12 times as many disks as the amount of storage you need. So let's look at more sane mirror configurations. If you just have 2 disks and we mirror them together, then we see that the read IOPS will be 500 because we can read from both disks at once, and so that gives us double the IOPS over a single disk. But writes, we still only get the writes IOPS of one disk because we have to do the write to both disks, and the same for the speed. And our storage efficiency is 50% because it takes 2 6 terabyte hard drives to give us 6 terabytes of usable space. But our fault tolerance is 1 because we can lose one of those drives and we're fine. So if we have 12 disks, the most common way to do that is to make 6 two-way mirrors. So we take 2 disks and make a mirror, and then 2 disks and make a mirror, and do that. So we end up with 6 mirrors, each having 2 disks in it. So that, as you can see from the graphic, every time we write the brown block, we write it to disk 1 and disk 2. And then the blue block goes to disk 7 and 8, and the pink block to disk 11 and 12. So we can lose any one of those disks, and we'll still have another copy of the blue block. But if we lose disk 7 and 8, if they both happen to die, or one dies, and then shortly later the other one dies, now we don't have any copies of the orange or blue blocks anymore.
And that's bad, yeah.
You only have a fault tolerance of 1. But in a best case scenario, you can actually lose disk 2, 4, 6, 8, 10, and 12. So you can lose 6 disks as long as they're the right 6 disks and never 2 from the same set. But now if we look at the performance numbers, read IOPS is 3,000, right? We get the read IOPS of all 12 disks. The write IOPS, we get half that. We get the write of 6 disks. So 6 times 250 is 1,500. Because every time we want to do a write, we can break it up into 6 pieces and write each of those 6 pieces to 2 disks, giving us 6 times the IOPS instead of just 1 times the IOPS. And same for the read and write speed. And again, our storage efficiency is 50%. We just need 2 times as many disks as we need usable storage. But, losing 2 disks is not that uncommon, right? Losing 2 out of 12, and it could be the wrong 2, and then you're hosed. So one option is the 3-way mirror. So with our same 12 disks, if we do 3 copies of every block, then we still have the 3,000 read IOPS, but we get down to 1,000 write IOPS because every time we write a block, we write 3 copies. So we basically have to take that 3,000 total IOPS and divide by 3 because we're writing each block 3 times. And the same goes for the streaming performance. We go from 1,200 megabytes a second to 400 megabytes a second because we have to do every one of those writes on 3 disks. And our storage efficiency drops to 33% because we need 3 times as many disks as we want usable storage. But it means we can lose any 2 disks and be fine, and technically lose up to 8 disks as long as we get really, really lucky. And never lose 3 from the same color stripe. So then it's just up to you to decide which of those trade-offs makes most sense for your data, or how you balance how much performance you need versus how much money you can afford to spend on extra disks. And as I said, we'll get into the interesting cases with RAID Z later
in
another episode.
Part 2. Yeah, there's a second part.
But yeah,
okay.
And you can add spares to try to lessen the window of if you're doing the two-way mirrors as we look at here, and instead of 12 disks you have say 14 and you have 2 spares available. If disk 4 dies, you can swap in the spare and hope it can finish resilvering all of the data off disk 3 before disk 3 also dies. But the strain of doing the resilver is most likely to be the thing that it might make disk 3 unhappy in the first place. And you really don't want to end up in that situation.
Yeah, better not. So. Yeah, definitely a good introduction to the whole pool and redundancy. And next up in our headlines is two-factor authentication with SSH on OpenBSD. So this looks like another how-to, and it is. So it starts with a little intro here. 5 years ago, I wrote about using a YubiKey on OpenBSD. So that's a little hardware token. The only problem with doing this is that there's no validation server available on OpenBSD. So you need to use a different OTP slot for each machine. And you don't want to risk a replay attack if someone succeeds in capturing an OTP in one machine, right? So YubiKey has 2 OTP slots per device, and if you need a YubiKey for every 2 machines with which you like to use it. So you could use a Bastion and use only 1 YubiKey, but the author here doesn't like the SPOF aspect of the Bastion. So your mileage may vary, but that's what they came up with here. So after they played a little bit with the TOTP, they wanted to use them as two-factor authentication for SSH. And at the time of the writing of this article, they can't do that using tools in base. And but they focus on OpenBSD in this article. But if you use another operating system, there are only a few things you need to change, and there are 2 handy links for those people who want to look at those. So there's a seed configuration section here. First of all, you need to install the login auth, and that's a package that you use with package install or package add. And then you need to create a secret, like the seed, that will definitely create provide the randomness here. And you provide that using OpenSSL with the rand function or the sub function here, and pipe that out into .totp-key, and then change mod 400 on it, because you only should be the only person to read that and no one else should look at that secret. And now that you have this hexadecimal key, apps usually want a base 32 encoded secret. So you initially, they initially wrote a small script to do the conversion, but while doing this article, they looked at the opportunity to improve it. And when they initially wrote this utility for their own use, the Python QR code hadn't been imported to the OpenBSD ports packages system yet. And it's easy to install now, so let's use that one. So that's a handy little utility to do just that. And here's the code for it. So now you can fetch this script from FTP. Here's the FTP site, and you can now check to make sure that everything went smoothly by comparing the code provided by your mobile app to one generated by the OAuth tool or Oath tool. Binary is provided by the package Oath-toolkit, and then the Oath tool accepts the seed in either hexadecimal or base 32. You can see here both invocation, and you see that's the same output. So that's the verification. And then you can also use a hex to B32 converter that you might have lying around, or write a little piece of code here that's provided in the article as well. So now what you do is you need to make your system configuration, and they can now move to the configuration of the system. And what you need to do is to tweak your login.conf. Be careful with that, because you could not only lock yourself out, but also make your system unusable. So keep a root shell open, so open a second one to make sure that you still get back into the system and can make changes as the system administrator in case something broke and you locked yourself out. Then you still have that other session. So here's the line. You can see there's the auth-ftp-defaults, and you see below that, or you add basically, you change that from equals passwd, auth-ftp equals passwd, and you change that to auth-ssh equals -totp. And when you're inside the class of the user account, so there are different classes in login.conf, and for this one, you choose the tc equals auth ssh-defaults. And here for the staff case, you provide that in your in that specific section. Now back to SSHD's configuration. You need to tell SSHD about this new way of authentication. So a good standard, of course, is to use password authentication no, and you use public keys only, which is recommended here. Except have a guess what the P stands for in TOTP. Yes, you guessed it. So we need to switch to password authentication yes, actually. And however, if we made this change alone, SSHD would then accept a public key or a password, which are TOTP because of our login conf. But two-factor authentication uses both at the same time. So to inform SSHD, we need to use both. So we need to set first authentication methods to public key and then comma password. And this way, the user is trying to log in will first need to perform the traditional public key authentication. So that's your public-private key that you have exchanged with the system. And once that is done, SSH will prompt for a password, and the user will need to submit a valid TOTP token for the system. And that way you have the two-factor authentication, first with the public key and then the password. So there's the diff provided in case you want to follow along here. You can see that the if you run this with SSH-v, you see what kind of communication is happening between client and server, and you can see that it's first asking, give me the proper password, or authentication that can continue password, and after you provided the password there, the correct one, of course, and then you succeeded with the authentication. So now you can improve on that, the security, without impacting the UX. So the author's phone here has a long enough password that most of the time it fails to type it correctly. Yeah, we've all been there on the first try. But of course, if he has to unlock his phone and launch the TOTP app and use the keyboard to enter what he sees on the phone screen, he would quickly disable two-factor authentication because it's too tedious. And to find a balance there, he listed or whitelisted certain IP addresses and users. And when connecting from a particular IP address or as a specific user, you don't need to go through two-factor authentication because you trust those networks or those users. But for other users, you might not even enable two-factor authentication at all. So to whitelist those, you can create a match statement in your SSHD config and say, for example, match user git authentication methods only public key without password. Or a specific IP address here for a VPN that you trust that's securely enough, then you can just say authentication methods public key.
That makes sense,
So,
especially you don't want to have to do the two-factor dance every time you do a git pull.
Yeah, it's a bit too tedious to do that. But yeah, it's a nice way of adding a little bit more security to an already secure system for authenticating yourself with a remote system and making changes via SSH, and then providing a password that you only generate on a certain device that you have with you. Very nice. And as they wrote, you pretty much can put this onto any other system by just changing a few things. So, time for the news roundup this week. We have an article here for you about how ZFS maintains file type information in directories.
Yeah. So as an aside to the article we covered the other day about the history of file type information being available in Unix directories, Chris mentioned that it was possible for a file system to support this even though Unix doesn't. By supporting it, I mean that the file system maintains this information in its on-disk format for directories, even though the rest of the kernel will never ask for that information. This is what ZFS does. One reason to do this in a file system is future-proofing against the day when Unix might decide to support this in a more general way. Another is if you ever want the file system to be a first-class file system on another Unix that does support this stuff, like say FreeBSD or OS X. In ZFS's case, I suspect the first motivation was larger than the second one. So the easiest way to see what ZFS does with this is to use the zdb command, which is the ZFS debugger. And we can use this to dump a directory entry. I could do like an entire series on just the zdb command. It is so useful to just print out the internal data structures from ZFS and look at them and see how they work. It says, I'm going to try to do this on an OmniOS machine to make it more convincing. And it turns out that this has some interesting results. Since this is OmniOS, we don't have the convenience of just naming a directory in ZDB. So let's find the root directory of a file system starting at dnode number 1. So zdb and then dash ddd, each additional D increases the verbosity of the information about the dataset. And then we provide a dataset name, so pool / dataset / child, whatever. And then the last parameter is the object number. And he's redacted a bunch of the information here, but we see that this first object is the root directory, and the root has an ID of 3. So we run this command again and read the root directory entry. So the first object is basically the dataset itself, and it contains a pointer called root in all uppercase, and that object is an actual ZFS directory object. And that directory contains files. So each file is its name. So everything that's in the directory is the key in this zap. If you remember, we talked about the zap a bit when the ZFS and Linux people had the disappearing files problem.
Yeah.
So the zap is basically a key value pair system, and the key is in a directory. The key is the file name, and the value is the object number. So if you wanted to investigate the object called CKSTST, you would just do the zdb ddd thing on object number 12017, which is a file and type not specified. Whereas this check test number 3 with object ID 25069 is a directory. And we can see, there's some regular files, some directories, and then some things that are not specified. So Chris goes on to say, this is actually an old file system that dates back to Solaris 10 and has been transferred around with ZFS send, pipe ZFS receive since then. But various home directories for real and test users have been created over time. You can probably guess which one is the oldest. Sufficiently old directories and files have no file type information, but more recent ones have this information, including the .demo file, which says it's a regular file instead of not specified, which I made just now so that it would have an entry that is a regular file with type information. So once I dug into this, it turned out to be a change that was introduced or activated in the ZFS file system in version 2. So ZFS has, there's a zpool version, which went from 1 to 28, and then that's when the fork happened, and OpenZFS went to V5000, and Oracle ZFS has gone on to like V32 or whatever. Separate from that is the ZFS file system version number. So not the pool version number, which is 28 to 5000, but the file system number, which has never changed in OpenZFS either. It went from 1 to 5 and has never gone past 5. So in version 2, which is described if you do ZFS upgrade-v and let it explain it, is enhanced directory entries. As an actual change in OpenSolaris, it dates to the mid-2007s, although I'm not sure that Solaris releases it actually ended up in. The upshot is that you can make your ZFS file system anytime in the last decade. You'll have this file type information in your directories. The only reason he's missing it in some of his is that his file systems are from pre-2007. So how ZFS stores this file type information is interesting and clever, especially when it comes to backwards compatibility. So he starts by quoting a comment from the ZFS_znode.h. The directory entry has the type currently unused on Solaris in the top 4 bits, and the object number is the low 48 bits. The middle 12 bits are unused, leaving them space for use for something else. Because, yes, in ZFS, you can have 2 to the power of 48 minus 1 files in each directory. So in yesterday's entry, the previous one about this file type information, he said that Unix directory entries need to store at least the file name and the inode number of the file. What ZFS is doing here is reusing the 64-bit field they have for the inode, or the ZFS dnode in this case, or the object number, to also store the file type. So since they have a 64-bit number for the object ID for each file in each dataset, they use the top 4 bits of that to store the type information. And they left themselves, was it 12? Yeah, 12 other bits to use for something else in the future.
Okay, interesting.
So yeah, this makes old directory entries compatible automatically because no one actually got around to creating 2 to the power of 48 individual files on a dataset. It means that all the object IDs are going to have zeros in the top bits already, and therefore are perfectly fine. Since old directory entries only stored the object number and that object number is 48 bits or less, the high bits are guaranteed to already be 0. It says, it seems common to define DT_unknown to be 0. Both FreeBSD and Linux do that as well. The reason this needed a new ZFS file system version is now clear. If you tried to read directory entries with file type information on a version of ZFS that didn't know to do this, the old version would just see a crazy high object ID number and try to find it, and it wouldn't be there. So the directory would point to a file that's not there. So in order to even read a file type in directory entries file system, you need to know to only read the lower 48 bits of the object number. So he says, as before, I consider this a neat hack that cleverly uses some properties of ZFS and file systems to its own advantage. If you think back, the other attack he was talking about was if you want to find out where a directory is, or if you have the object number like this, and you want to know the file name. The key value pair doesn't work both ways, so you can't do that. But if you know this object number and you look it up with the zdb command, one of the properties will be parent, which will be, if we did this on demo file, it would be 3. So then you look up object 3, which is the one that contains demo file, and then you can just go through this zap and find this object number and immediately find the file name.
That's the reverse lookup.
And that's why, on UFS, if you have the inode number and you want to find out what the file names are, you literally have to do a find on the inode number and search the whole file system and see if you find it. In ZFS, you go up a directory and get the metadata, and you can do this really quickly for thousands of files, and that's how ZFS diff or zpool status -v can tell you the file names of files when they change or get corrupted or whatever.
Cool. All right. Yeah, so all these little bits are in ZFS code, and our next story here is everything old is new again. So starting off with, just because KDE 4 era software has been deprecated by the KDE FreeBSD team in the official ports repository doesn't mean we don't care for it while we still need to. So that's about KDE 4 and FreeBSD's port system. And KDE 4 was released January 11, 2000 8, the author still has the t-shirt, which was a very different C++ world than what we now live in. Most of the code predates the availability of C++11 and certainly the availability of compilers with C++11 support. The language has changed a great deal in those years, or 10 years actually, since the original release. So the platforms we run KDE code on have too. FreeBSD 12 is a long way from the FreeBSD 6 or 7 that we were currently that they had when that KDE 4 came out. And although at the time it was more into the author was more into Open Solaris, but still. In particular, since then, the FreeBSD world has switched over to Clang, and FreeBSD Current is experimenting with Clang 7. So we're seeing KDE 4 era code being built and running on FreeBSD 12 with Clang 7. That's a platform with a very different idea of what constitutes correct code and what the code was originally written for. Not quite as big a difference as Helios or KDE 1 efforts though. So while we're counting down to remove KDE 4 from FreeBSD port 3, finally, we're going through and fixing it to work with Clang 7, which defaults to a newer C++ standard and which is quite picky about some strings, or some things actually. Sometime in the distant past, when pointers were integers and null was 0, there was some confusion about booleans. So there's lots of code that does list.contains passed by an element greater 0. This must have been a trick before booleans were supported type on all our compilers. In any case, it breaks with Clang 7, since the contains function returns a qbool, which converts to a null pointer when that when that returns false, which isn't comparable to integer 0. Of course, the one is a boolean and the other one is an integer. Suffice to say, the author here spent more time reading KDE 4 era code this month than in the past 2 years. Oh dear. However, work is proceeding at a quick pace, so if you really, really want to, you can still get your old school kicks on a new platform, because we care about packaging things right, even when we want to get rid of it. So yeah, that's the nice thing that people do, and making it compatible with newer versions, even though they came out 10 years ago. So thanks for those efforts, ports people. It's appreciated.
Yep. And next up, we have a bit on Netcat.
Mm-hmm.
Everyone's favorite Netcat. So, OpenBSD has its own version of Netcat, which is what the FreeBSD version is a copy of the OpenBSD version. Owing to its versatile functionalities, Netcat earns a reputation as the TCP IP Swiss Army knife. For example, you can create a simple chat app using Netcat. You just netcat-L in a port number, and you're now listening, and someone can connect by just doing netcat, the IP, and the port, and you can type messages back and forth. A primitive chat room is built successfully. Very cool, isn't it? But I think many people can't wait to explore more of the features of Netcat. If you are among them, congratulations. This tutorial might be the right place for you. In the following parts, I delve into Netcat's code to give detailed anatomy of it, the reason for picking OpenBSD's Netcat rather than others that might be out there, and so on. Furthermore, I also hope this little book can assist you in learning some socket programming, not just grasping usages of Netcat. I've been using Netcat a lot lately as a transport for ZFS replication.
Oh, yeah, I use it to, when I set up a new server using the boot, the FreeBSD ISO, I start the shell and then set up the networking, like DH client, IP address, and then I just use Netcat to send the install script over and then just run that, and after 3 minutes, the server is set up. Yep. And it's only possible because Netcat has these very primitive, send and receive functionality. That's all I need, and no need to, start a server here and over there. I need to do a copy and SCP or whatever. It's a quick and easy way to copy files around.
Yeah. Netcat was one of the first things in the base system I touched. I think it was just the man page, though. At some point, OpenBSD had changed something and that had been imported into FreeBSD, but the man page hadn't been updated. And so the example was wrong, I think. Yes, one of the examples in the man page, it was even wrong on NetBSD, or sorry, OpenBSD. Yes. Because of a behavior change, you needed the capital N flag so that Netcat will close when the pipe feeding it closes.
Yes, yeah. Otherwise it hangs forever.
Yeah. And the example in the man page didn't work anymore because it was missing that. And so I did the whole dance of getting it fixed in OpenBSD and then importing that onto FreeBSD.
Excellent.
That was one of my first real interactions with the base system and with importing stuff from via a vendor branch and so on when I was still a doc committer. Anyway, so OpenBSD's Netcat can support both network sockets like TCP and UDP, but also Unix domain sockets. So in this example, if you do -L -U and a path, it will create a Unix socket there, and you can then listen on it. So when look in the code, the -L options basically just sets an int called L flag to 1, and then later in the code we do something with that. You can also use the -4 or -6 options to force it to use IPv4 or IPv6 only, and by default it'll do both. The Netcat program also has a family variable, which can be set for those. So family starts as unspecified, but can be set to, v4, v6, or Unix, and so on. So when we look at the code here, we can see that if you set the -4 options, it sets the family to inet, and 6 sets it to inet 6, or U sets it to family Unix. And if you pass -L, it sets the L flag variable to 1. And then we can see how it works here. So if it's a Unix domain socket, then Netcat only needs one argument, which is a Unix domain socket. Whereas if it's a network socket, you need both an IP address and a port number. Then in this case, a binding with a wildcard address, default to binding to the v4 address. So if the host is null and the family is currently unspecified, then we will default to IPv4. So when you just do netcat-L 3003, it'll listen on that port. And the tutorial goes on and on to cover how you actually figure out the port numbers and stuff, how to switch to UDP. So if you patch -U, it switches to UDP, and you can see how it changes the code there. How to launch a server service so that you can listen on a socket. How to connect. And you can see they implement it with a timeout. How to read and write to sockets. How to do Unix domain sockets. How to use socket options. So using, set the debug flag or the MD5 signatures and various other flags you might want to set on a socket. How to actually do SSL and TLS sockets.
Yeah, because up to now it was all unencrypted.
And how to do port scanning with Netcat.
A quick and dirty way. Yep.
While it's also a great tutorial on using Netcat, it's also a very nice way to get the basics of how to write socket code in C. So yes, this is a very nice walkthrough if you want to get started with a little bit of C programming involving sockets, or just better understand what's going on inside the Netcat command.
Yep. Cool. Time for BSD Bits this week. We start off with what's in store for NetBSD 9, and people think, this is your BSDCon presentation, and that's exactly right. You can see what NetBSD 9 will bring you if you couldn't attend the conference. And it's the full presentation. There's a lot of stuff.
If you're interested in NetBSD and what's going to be in the next version, then check it out.
Also in the NetBSD area, NetBSD machines at Open Source Conference 2018 Hiroshima. So
Yep,
this is
their table set up with all the classic hardware.
Oh yeah, here we go.
Very NetBSD.
Yeah, because it runs NetBSD and they might as well show it off. But they also have Raspberry Pi 3.
A presentation about sound and how that works on NetBSD from the conference.
Very nice. Yeah, these are the machines you don't see very often unless you have those somewhere under your desk. But yeah, this is nice to see that NetBSD supports these. What's next is that NMCTL adapted with limited privileges. So this is NMCTL 060 over at Vincent Delft's blog. And as stated by some users, it's dangerous that NMCTL runs with root privileges. So this version of NMCTL runs with standard users and delegates to do-as the management of privileges.
I think this is the network management script we've talked about before.
Yeah, that they recently introduced or changed to have that separation. Oh right. Yeah, here's the cable and there's the home Wi-Fi. Yeah, to switch between in case.
Yeah, so this is a user program for managing connecting to different networks on your laptop. And yes, they've made it more of it run as a regular user and just use do-as to execute the ifconfig commands and so on.
Mm-hmm. Very good. And as this year almost comes to an end, we have things to look out for in the future. So there's Scale 17X and FOSDEM 2019 call for papers already out. They're out or they're linked from the FreeBSD Foundation blog. And you can still submit your talks or also I think they do tutorials or workshops. So Scale 17X is March 7th till 10th, 2019 in Pasadena. And submission deadline is October 31st, so end of this month. And they look for things like open source in enterprises, containers, and orchestrators. Orchestrator, as well as open data and security. And FOSDEM 2019, which is a good place to meet Alan and me. That's February 2nd till 3rd, so that's the weekend. And that's in Brussels, Belgium, like all the years before. And the submission deadline here is November 3rd, 2018. So a little bit further out, but don't miss that one. There will also be a BSD dev room. We just got the word that it's a full day dev room, and we need to have people submit to that dev room in case we want to have a nice program of interesting BSD talks there on the Saturday, depending on which they haven't decided yet when it's going to be, but it's going to be a full day.
Right, it'll be Saturday or Sunday. Yep. I need to polish my talk for the main track because the deadline is Friday.
Yeah, that would be good to have.
The deadline for the first round is, the 13th, but in Europe, so that means Friday here. So I have some stuff written in the proposal in their pentabarf, but I think it would be rejected in its current form because it doesn't contain enough detail.
Needs more polishing. But yeah, do the same as Alan did. Write something. The worst thing that could happen is that it's not accepted. But if it's accepted, then you give a talk at a very, very big conference in Europe.
Yes. Don't underestimate the fact that it's 8,000 people.
Yeah, a lot of open source projects are there. And it's definitely worth going.
And EuroBSDCon, the big version is like 350 people or so. So 8,000 people is just a different thing altogether.
Yeah. So yeah, definitely try to make it. And next up in our list here is OpenBSD 6.2. The site is up at least. There's no release yet. No pressure there, but it's going to be released November 1st, 2018. On that day, they promised that. And there's no title graphic yet or any songs listed there, but there's a preliminary release notes page up, and you can see a few of the what's new and what has changed lists there. It's still being edited a little bit, but for people who are interested in looking ahead a little bit, there's the list already, what's new and what drivers and what changes were made. Okay, very nice. And we have an article here talking about using Alpine to read your email on OpenBSD. So this is over at Black Cat Enterprises. Oh, it seems like the site is gone, at least 404 for me.
Or I'm guessing they changed the blog post or something since we
Could
linked
be.
to it. All right. Well, maybe we'll come back to that one next week. Or maybe their static site generator broke because they don't have any content on their site at all.
That it seems like it's slash-dotted, but
Well, no. It's a static site generator called Ghost, and there's no content at all, so I'm guessing a build broke there. We'll come back to that one later.
Yeah.
Okay, on to the feedback.
Exactly, yeah. Send us feedback. We need always to have something in that section. If you don't submit us any questions, then it's difficult to answer them. So send those to feedback@bsdnow.tv, like Morgan did, about ZFS send and receive to manage fragmentation, ? That goes like the following. Hi guys, my company makes extensive use of BitTorrent sync for internal data. The main server stores the data on ZFS datasets in FreeBSD. So in accordance with the OpenZFS recommendations on BitTorrent, I've already set record size to 16K and redundant underscore metadata to most. And as you may know, however, data received via this protocol is often extensively fragmented on disk. I know that performing a local send and receive of a dataset can be useful for certain housekeeping tasks, like ensuring that a change to a dataset property is fully propagated. And does it resemble fragmented files as well?
Yes, so a ZFS send does reassemble the file. So when you send it across, the file is going to be one contiguous chunk, but when you receive it, the receiving side, if its free space is fragmented, won't be able to write it as one chunk and will have to re-break it up. It'll break it up better, so it'll improve, but it really depends on how fragmented the free space is on the receiving side. But in general, yes, this will help a lot and defragment the files. The way I've actually implemented this on my system, the BitTorrent client downloads to a separate data set that has like the 16K record size and redundant metadata and so on. But when the torrent client is done downloading the file all out of order, it actually copies the file to a different directory, a different data set, where it'll basically be, as part of the copy, defragment it. And that data set has 1 megabyte record size and writes out the files as big contiguous chunks. So each file as it's done downloading does this, and it means I don't have that same problem. But it's different if you're doing something like BitTorrent sync, where you're going to be doing this all the time, or the file's changing all the time. But yes, ZFS send receive will defragment your file as long as you have free space that isn't fragmented to defragment the file into.
Yeah, it needs some space to handle that. Yeah, and there's also the question, might it be worthwhile to schedule a periodic task to perform a local send and receive to move the files to a fresh data set in an effort to manage fragmentation?
It can be if so the problem with doing that, so you can, first of all, you would need twice as much free space, right? You'd need, if you have, a terabyte of data, you need another terabyte of free space to write it into. And, if you barely have that, then that's going to increase fragmentation. But the other thing is dealing with changes to the data, or open files in particular. So if none of the files are being used right now, then you could do that. And you can help with basically do the first send, which might take a long time if it's terabytes of data, then do another snapshot and do an incremental and get caught up. But once you're ready to make the swap, you need to make sure none of the files are open and nobody is using them. Then you can swap the two around and throw away the old one once you're happy that the new one is working. So yes, although I'd be a little hesitant to automate that, just because if something goes wrong with the send and then you throw away the old one and the send copy isn't 100%, like if it didn't actually copy and you didn't notice, you might throw away your data.
Yeah, be careful with these automations before you haven't tested them. It's quite a loss. Okay, I hope that answers your question. And yeah, thanks for sending them. Next up is Ryan with ZFS and Nmap. So let's just quickly. Is it possible to use ZFS with LZ4 compression with Mmap applications? And what operating systems support Mmap on ZFS with LZ4 file system compression? NetBSD, Linux, SmartOS, FreeBSD?
I know FreeBSD does. I don't know about the rest. Now, the LZ4 compression is on disk and on new enough FreeBSD in the ARC cache, but the content when it's Mmapped is not going to be LZ4 compressed. So when you Mmap a file, you're going to copy the data from the ARC to the OS's buffer cache and Mmap that, and then modify it, or read it from it and maybe modify it. And then when you're done, when you flush it back, it'll be copied back into the ARC and then written out to disk. And that's when it copies back into the ARC or gets written out to disk. One of those steps is where the LZ4 would come in a second time and recompress the changed data. So basically, the two don't have anything to do with each other.
Yeah,
the problem with doing LZ4 on the data in memory when you're mmapping it is the whole point of mmap is that your application just gets pointers to the data in RAM. And now the idea with mmap is you could have a file that's really big, maybe bigger than the amount of RAM you have, but you mmap it and you get pointers to the whole file in order. And then not all of that's actually in RAM, and then as you access a bit of it, it gets copied into RAM, you use it, and then, you know, if there's a bit you haven't read in a while, it might get pushed back out in order to make room for you to read another bit of the file. And it makes it very easy to just treat the whole large file as one big region of memory. And then if you do writes, then the bits you change can get written back out to the disk and let you change the middle of a big file without having to, you know, manually read and seek through the file. So mmap support is there on FreeBSD. I'm pretty sure it's there on Illumos and Linux. I'm almost 100% sure. NetBSD's ZFS, I don't know the state of it, but I would imagine as well.
It's coming along, I hear, yeah.
But so LZ4, it happens at a different level than mmap. So it'll get de-LZ4'd before it goes into mmap and re-LZ4'd when it comes out of mmap. If it's changed. If it's not changed, then we can just throw away the mmap copy. So, yeah. I hope that answers your question.
Okay. Next up is Marcus or Marcus with Linux compatibility, asking what is the state of Linux compatibility in FreeBSD or TrueOS these days. He tried it about 6 months ago, and at least on TrueOS it conflicted with the latest graphics drivers. And while he is on that topic, should this allow him to run Linux graphical applications, or is it simply for command line utilities?
So the Linux compatibility in the kernel side emulates basically the CentOS 6 kernel. However, then there's the port side where we provide the support libraries, and that you can choose between CentOS 6 and CentOS 7.
That's a bit more modern, yeah.
Yeah. But yes, I'm not aware of anything that would make the Linux compatibility stuff not work with graphics. They're kind of quite separate and shouldn't conflict at all. I don't know if it was a package problem on TrueOS or what. And then for graphical applications, it kind of depends. If all of the dependencies of the graphical application you're trying to use happen to be included in the CentOS package set we provide, then yes. Otherwise, it gets quite complicated.
Depends always how deeply nested Linux is.
A useful Linux graphics application, it might already be in the ports tree and take care of it all for you. There are a number of applications. I don't know if we still offer the Linux version of Firefox in the ports tree or not. I don't think so. I've never tried to use that in the last 5 years.
Difficult to maintain, yeah. And you're not talking about games that way. So it's another thing to emulate graphical things like Linux games that were ported to Linux.
Yeah, but if a game's been ported to Linux, well, I guess it's a commercial game, maybe not. But most of the other ones are available as native, and you don't need to use the emulation thing.
Mm.
I know that like there's a port of like Linux Java.
Yeah, in case you need that one.
And so there are a number of applications available.
Yeah, it mostly depends on who has the need to port applications that aren't natively available on FreeBSD. And luckily, people have ported most applications to FreeBSD native by, rewriting paths that are Linux specific or making patches available to make that work on FreeBSD. But there's some applications that are so Linux infested, let's say, that we need to run the Linuxulator on it to make that work on FreeBSD without too much modifications.
And as Nicholas points out, there are a number of people working on trying to get the Linux version of Steam going. And I know on TrueOS they have the Windows version of Steam going.
Ooh, excellent. Yeah, that's exciting. And I guess that's people what they are looking for the most to run their favorite games on a BSD platform. Okay, yeah, I think if people have more about this or use that maybe or have a game running or some graphic applications, then definitely send this to us and we'll cover it in a future episode. Maybe a blog post to how to get started or make that work. That would certainly be interesting to a lot of people. And so last but not least, Ben with a question about multiple pools. So that goes. Daily ZFS user and loving it. Welcome to the club. I often find myself in a situation where I would like to have a hybrid use pool, which could host both file storage for containers or NFS, but also virtual machine images. So typically, I create two pools, one fast with SSDs for the virtual machines, and one slow with HDDs for the file storage. However, this causes a split in the two pools, meaning you have to handle the free / used space in two pools instead of one, and you lose a lot of the benefits which ZFS provides in having a single pool. An ideal scenario would be the ability to add both SSDs and HDDs to a pool and instruct a given dataset to prefer one disk set over the other, or allow them to cross these boundaries if space needs require that. Does anything like this exist in ZFS, or is there something similar which could accomplish this goal, or is it the best method to use two pools?
So some of this is starting to arrive. At the OpenZFS Developer Summit last month, we actually talked about the introduction of the allocation classes feature to ZFS, which allows you to create special VDEVs. It's actually the keyword is special instead of mirror or RAID Z. And those have some ability to control what goes on them. So I think by default, you can set it so that all metadata about files goes on the SSDs and the data goes on the spinning disk and so on. And also anything that's really small blocks that could benefit from it will go to the SSD. So that combined with the work I'm doing on VDEV properties so that you could have an easier way to express what you want written to that SSD. And then maybe, yes, some pool properties, or sorry, not pool, but dataset properties where you could say, prefer allocations from here. So maybe in 2020, this will be a mainstream thing. I think the practical way to do it is to somehow have markers on VDEVs that define like the class of VDEV they are, or tier or something. And then on a data set, you would say, I prefer to be written to tier 1 storage for SSDs or tier 3 storage or whatever. I haven't quite figured out how I'd want that to look. But work is slowly progressing in that regard. And I could make things go faster if if people are interested in this hybrid storage type thing, they should get in touch with me. And if we can put a pile of money behind it, I can get people to work on it.
Oh, that's an offer. Yep.
Yeah.
So that's certainly a feature that people are looking for, because the more they use ZFS, the more different use cases they have. And as Ben said, having two pools separate for just different types of I/O or these types of classes would be bad by dividing it this way. But having one pool that is intelligent enough, whatever that may mean.
Well, no, you definitely wouldn't be. Well, so this with the special class, you can do things like if the block is very small, use the SSD and so on. But yeah, it's mostly coming up with a nice admin interface to this that makes it simple to use and not complicated, and doesn't lead you into nasty corner cases.
Yeah.
Because there's also talk of using this to, say, have an SSD dedicated to the dedupe table and things like that.
Yeah, that would be the persistent.
And the other thing is, when you start defining these tiers or something, then you get the problem of, also, I have tier 1 is SSD and tier 2 is 15,000 RPM drives, and tier 3 is my archive drives. Suddenly I have NVMe or NVDIMM storage now, and I need like a tier -1.
Yeah, where does this end?
Yeah, and so
what's the next iteration of that?
Come up with a way that makes sense. Because you want some kind of ranking so that, you know, if the SSDs are full, you want those writes to go to the next best class, not randomly go to, you know, spinning disks.
Yeah, but couldn't ZFS kind of measure how fast each storage medium is? And
not really. And even then, that's probably not what you want. You want to say the database always goes over here and the random files never go over there, kind of thing.
Yeah, it's not all about speed. Yeah.
Yep.
Yeah, it's difficult, but definitely an interesting problem to solve, and ZFS would be perfect to that. I mean, I can't imagine this would be going into ext3 or 4 first, because yeah, it's not made for that. Okay, but that's pretty much wrapping up our show for today. Remember, we're at MeetBSD, so we'll definitely tweet and give out interesting thing from the conference. And once we're back, we, of course, will report about the whole thing, what happened there, and the talks we saw.
Yep. All right, see you next week.
See you.